Hello everyone, I hope you are doing well. So in this video, we're going to discuss the solutions for the first three problems of Codeforces round 821, which was rated for Division 2. So let us quickly start with the first question. The first question says that we have been given an array with n integers, the size of the array is n, right? And we have to perform like these operations at most k times. So the operation involves choosing two indices I and j such that I mod k is equals to j mod k, and we have to swap them, right? So we can do this particular operation and we can do this at most k times, and we have to find the maximum sum of any k consecutive elements in the whole array after performing at most k such operations, right? So we have to find the maximum sum. So let me give you a better idea of this particular question. So for example, this is a1, a2, a3, a4, a5 and a6. So if the value of k here is let's say 3, right? So we can take the value of k as 3, and let us take 0 based indexing, so I can also include a0. So now this particular index is I equals to 0 and this is I is equals to 3, right? So if we like mod it with 3, then these two indexes will be together, these two indexes will be together, and again these two indexes will be together, right? So these process so it means that we can take, like, again, if we try to extend it, then with 3 this particular 6 would be together, and if I write a7 with a1, it will be together with a7. So we observe that there form some groups of elements. So if, for example, a0, a3 and a6 are in the same group, a1, a4 and a7 are in the same group, so we can observe that we can take the maximum of these. So for example, if I take a0, a3 and a6, I can take the maximum of these, and let us assume it is a6. So I can take a6 and put it in the first place in one operation, right? Similarly, I can do it for a1 and a2 for the groups in which a1 and a2 are present. I can take the maximum and put at this particular position. So let us assume that this is the maximum of group 0, this is the maximum of group 1, and this is the maximum of group 3. So if you take the sum of all of these, this would be the maximum sum of the k consecutive elements, right? So we just have to traverse through all the groups and find the maximum element in each of the groups and find its sum. So this will be the solution for the first question. So this is what how do we do it in the code. We take two integers n and k, and we take a vector of size n and take input map. And now I have initialized the sum with 0, so I just run a loop from I, from initially starting from 0 to less than k, right? Because we'll be having k consecutive elements. Now I initialize the maximum value as b of I, and I start a loop from j is equals to I till less than n, and at each iteration I just increment j by k. So what will happen is, initially it was at a0, next if I increment it by k, it will go to a3, then it will go to a6. So this is how it will continually keep on going, and I find the maximum of all of these elements and finally add the maximum element to the sum, and at the end I'll just print the sum. So this was the solution for the first question. Now moving on to the second question. So the second question was just some observations. So if you notice that there is a game in which n players are there, and the method of the game is like two adjacent players. Initially, all of them are arranged in like in a sequential order, like 1, 2, 3, 4, and up to n. Right. So initially, player 1 and 2 plays the game, and then the winner plays the game with player 3, and then the winner plays the game with player 4. So always the adjacent players play the game. Now each player has either won X games or Y games in the championship. This information has been given. So we have to find a result of those n minus 1 matches if it is possible. Otherwise we just have to print -1. So if there are 5 players, then there would be 4 games only. So the main observation is, the observation one is, if both of them are 0, then the answer is -1. If both of them is non-zero, then the answer is -1. In all the other cases, if one of them is 0 and one of them is non-zero, then the answer would be a valid answer. Now let us discuss why this is true. So if both of them is 0, then if there are two players, then none of them would win a single match and we cannot continue any game. Like we cannot form any game, it is very obvious. But what if both of them is non-zero? For example, A is equals to 1 and B is also equals to 1. So let us assume that player 1 wins a amount of games, that is 1. So if player 1 wins 1 game, then player 2 will be winning 0 games if we just consider these two players, right? Player 2 will be winning only 0 games. So neither B is 0, neither A is 0. So 0 does not belong to either A or B. Therefore, the answer would be -1. Because player 2 also has to win either A number of games or B number of games. So either of them should be equal to 0. Right. Now, if one of them is 0, let us assume that A is some value 3 and B is some value like we can assume it to be 0. Right. So if there are let me take 7 games, seven players. So if I write all of them, right, so I can just start with the second player. Now each of them should win 3 games or win 0 games. Now I can start from the second player and it will win a game with 2, then it will win a game with 3 and it will win a game with 4. So 2 has won 3 games, right? Now I take 2 to this particular position and till here all of it is complete. Now 2 and 5 will play a game. Now since 2 has already completed all its games, it will compete with 5 and 5 will win here. So 5 will win with 2, 5 will win with 6 and 5 will win with 7. So it will be 5, 5 and 5. So this is how we will form, this is how the pattern of our question will look like, or the pattern of our solution will look like, right? But what if there was an 8 here, right? Then when we compete till here all of them is done. Now if we initialize a match between 5 and 8, either 5 would win or 8 would win. If we make 5 win, then 5 would total win 4 number of matches, which is neither equal to A nor equal to B, right? So this is a wrong configuration. If we assume that 8 wins, then the number of wins secured by 8 would be equal to 1. And again, neither A is equals to 1 or nor B is equals to 1. So here we observe that the solution is only possible when n minus 1 mod k is equals to 0. In all the other cases, the solution will not be possible because the number of games won by some player would be not equal to A. Right? There will be at least one player whose wins is neither equal to A nor equal to B. So we have to make sure or take care of this condition as well. So let us have a look at the code. Now I take three integers n, A and B as input. Now if A is equals to 0 and B is equals to 0, I have taken XOR of both of the values, right? So XOR denotes that one of them will return true, another of them will return false. So if both of them returns true or both of them returns false, then the answer would be -1 right away here. In any other case, I just initialize A with maximum of A and B. So I store the non-zero value in A. Now I check if n minus 1 mod A is equals to some value. If it is non-zero, I'll just print -1. Otherwise, I'll print my final answer. So my final answer will look something like this. So let me just erase this. I had complicated it a little bit. You can also write it as like this, right? So I initialize the count with 0. Count will take care of the total number of matches that have been taking place till now, right? So what I do is I initialize I with 2 and count should be less than n minus 1 because there are n minus 1 matches, and at each step I increment I by A, right? So I is the player that would be winning at the current moment. So I should win A times. So I'm initializing another loop from j is equals to 0 till less than A, and I print I A number of times, and every time I increment count. As soon as the count hits n, the n minus 1, then all the games would have been printed. So I just print a new line and exit from my loops. So this is how you could solve the second question. Now moving on to the third question and the final question for this video. So it says that we have been given an array of n integers and we can apply the following operations on it. We can choose two indices L and R, and if the sum of elements at positions L and R is odd, then we have to move the left element to the right place, and if it is even, we have to move the right element to the left place. So let me give you an example. If this is AL and this is AR, if their sum is odd, then I have to copy this value to this position. If their sum is even, then I have to copy this value to this particular position. Now there is a really simple, there's one more thing. We can make at most n operation, and this whole part copying one value through the other is counted as one operation, and we have to make at most n operations such that the whole array is not decreasing, right? So it should be sorted in ascending order. So there's a very simple observation to this question. If I have some elements like this, right? So when is the sum of two numbers odd? The sum of two numbers will always be odd when either one of them is odd and another of them is even, right? That means their parity is different, right? And when the sum will be even, either both of them are odd or both of them are even. That means their parity is same. So if their parity is same, I have to move the right element to the left place. If the parity is different, I have to move the left element to the right place. Right, so this is different. So what I can simply do is I can just check the parity of the first element, right? So if I know the parity of this element, then I can check all the elements which have the parity same as A1. So let us assume that this element has the same parity, this element has the same parity, right? So if all of these elements A1, A3 and A5 has the same parity, what I can do is I can just take A5 and copy its value to A3. Why this is possible? Because they both are either odd or they both are either even, right? If they both are odd or both are even, then the sum would be even and I can move AR to AL, right? So I take A5 to A3, so this will also be equal to A5, right? And again I can copy this value to this particular position because the parity is same and the sum would be even, so this will also be equal to A5, right? Now I take all the places which have the opposite parity as the first element. So what I can do is, if these two, if this particular element and the second element have different parity, then their sum would be odd, right? If their sum is odd, what I can do is I can take this value and copy to this position, then this would be A5, and again this particular thing, and again the element at first position and A4 have different parity, right? So I can again copy from this position to A4, so this will also be equal to A5. So this is how I can make all the values equal and the number of operations will always be less than or equal to n. So all of the values here are equal to the last element, and this will work in all the cases. Let us see the code. So here I have taken an integer n and I create a vector v in which I take the input. Now if the value of n is equals to 1, the answer can be straight away 0 because the one element is itself sorted. Now I create a vector res which is of type pair in which I will be storing the result. So I take the vector t and I push back 0 to it. I will be storing the elements which have the same parity as the element in the 0 at the 0th index. So this 0 is the index of that element, right? So what I am doing is I am just running a for loop from 1 to less than n, and if the parity of the ith element is equal to the parity of the 0th element, and I just push back into the t vector and I start a for loop. It's a reverse for loop, and here it should be n minus 2, right? So I'm just starting from the reverse position. So I'm taking the second last element, that is will be stored at t of I. I will be pointing to the second last element. So I just take the second last element and the last element, right? I plus 1th location, and for one base indexing I just add 1 to both of them. So this way I'll be making all of them as pairs. So what happens is, in the T vector, in this, if you consider this particular scenario, this was A1, A1, A3 and A5 were together in the T vector. So I just push the index of A3 and A5 and then the index of A1 and A3, right? So I'm pushing these indexes into the my result vector. So once I have done this, what I do is I just take a for loop from 1 to n. If the parity of the 0th element and the ith element is different, I just push the first location and the ith plus 1th location into the result vector. So now I'm completing the second part of my answer. So I can just easily print the result, the size of the result by res.size, which is my result vector, and I can traverse through this vector and I can print its first value as well as the second value together, which will be showing the indexes. So this was the solution for the third question for today's video. I hope you guys were able to understand the solution. So till the next video, docs, keep coding, stay safe, bye bye.